Welcome back. Today we'll be looking at bisection method, a very simple method under the intermediate value theorem. What is bisection method about? In normal mathematics, let's say we have a line AB. To bisect means to divide the line into two equal halves. So when we divide it, it's going to be like this. The M is the midpoint of the line. It's the middle of the line. So what is bisection about? Bisection is about dividing the interval into two. In the last video, we talked about domain and interval, and I said something like domain can be represented as I, which is the interval, and we have the lower point and the upper point. A is the lower point, B is the upper point. So bisection method involves dividing these points into two. Okay, so at every iteration, we need to divide the interval into two and find the midpoint. That is the syntax of bisection method. So let me show you the procedure. Number one is you have to choose the given interval A and B. Choose A and B. There's a condition, you can't just choose anyhow. The condition is that when you put A into the function and you put B into the function and you multiply the two of them, it must be less than 0. That is, function of A times function of B must be less than 0. Remember the rule of IVT. IVT says if a function changes sign in a closed neighborhood bounded by A and B, then the function has at least one simple root in the neighborhood. We bring that same concept into the bisection method such that once you choose A and B, your interval the multiplication of their functions must evaluate to a number less than 0. It must give a negative number. If this is not satisfied, that means your interval is wrong. You have to choose another interval. Basically, f of A times f of B must always less than 0. Number two, let's estimate. I told you it involves getting the midpoint of the interval. So we'll estimate the midpoint, which will serve as the root at every iteration. So M is going to equal to A plus B over 2. So you just find the average of the intervals, sum the intervals and divide them by 2. That is the midpoint at every iteration. I is equal to A and B. I've told you that's the domain, that's the intervals. We're going to add both intervals and divide by 2. That will give us the midpoint. And that is the root at each iteration. Number 3 now, you're going to evaluate. Based on what you have, you'd do some findings, some calculations, f of A times f of M. When you multiply f of A times f of M, there are possibilities. You have A and B now. This is M, the midpoint. So when you evaluate, for example, if f of A times f of M returns a negative number that is less than 0, that means there's a root between A and M. That is a valid point, it's a good sign. That means there's a root between A and M. Let me show you on the number line. Yes, that is where the root lies. You don't need the other part anymore. That means this is going to be your new interval in the following iteration. So let me just reiterate now. If f of A times f of M is less than 0, that means there's a root between A and M. You don't need the B part anymore. In your next iteration, A is going to be A, while your B in your next iteration will be M. Do you understand now? So that's about that. The next possibility is if f of A multiplied by f of M returns greater than 0. That means the root does not lie between A and M, basically. That means the rule does not lie between A and M. Eventually, if you do f of A and if you do f of B and f of M, it's going to be less than 0. Understood? Now, A, M, and B. If f of A times f of M returns greater than 0, that means there's no valid single root between A and M. You're only dealing with B and M. So that means it's going to be M and B. In your next iteration, M is going to be your new A, while B remains the same. Now, if f of A times f of M is going to be 0, terminates the iteration. That is the end of that iteration. And at that point, the root is going to be equal to M. That means you don't need to go to the next iteration. You've gotten the most appropriate value for M. So basically, this is the procedure. This is the set of rules guiding bisection method. If you understand this, you'll be able to solve any question using the bisection method. Next step, I'm going to solve two questions so that you can see and understand it better.
Hello, so press the like button. Thank you.
Hi guys, so let's get started quickly. The first thing we're going to look at is finding f of a and f of b. All right. So let's do it here now. Let's say I want to find, make it bigger so you can see it. So let's say I want to find f of a. All right. All f of a means you're going to substitute the value of a into this formula. Before we get started, let's write our a and our b. From this, you can see that our a is -3 and our b is what? 0. So let's get started again. So let's find, say we want to find f of a. This means you substitute the value of a into this original function. All right. So it's going to be f, that is, it's going to be 5 times a squared. A here is -3 times -3 squared. All right. 5 minus 3 squared minus 2 times -3 minus 24. Right. So -3 squared is going to be 9. So that is going to be 5 times 9 plus 6 minus 24. 45 plus 6 minus f of a. Good. So let's find f of b now. So f of b is going to be, substitute the value b into that is 0 into the original function. So we have 5 times 0 squared minus 2 times 0 minus 24. We have 0 minus 0 minus 24. So we can see that f of b is equal to -24. Now, just like what I said before, we are concerned with the polarity, with the sign on this. Okay, the sign on this. So we found for a and b, and we can see that if we multiply f of a times f of b, if you multiply it, you're going to get a negative value because this is positive and this is negative. So if we do f of a times f of b, whatever we get here is going to be less than 0, which satisfies the condition for IVT. Do you understand? So that means you can move forward. That means our interval here is safe. It's usually better and it's a good practice for us to, always check the interval by doing this. Because if you don't do this, you would waste a lot of time trying to calculate when the interval does not exist. Okay? So let's move forward now. Let's move forward very quickly. Okay, let me okay. So let's move forward now. The next thing we need to do is to find m. I told you we need to find the midpoint. Let's find the midpoint. M is equal to, according to the last thing I showed you, m is equal to a plus b over 2. So this is the first iteration, okay? So I call it iteration 1. So a here is -3, b is 0. -3 plus 0 over 2. So m is equal to, from here we can see that m is equal to -1.5. -1.5. Alright? So the next thing we need to do is to find fm. Let us calculate f of m. So let's say we want to calculate f of m. It's going to be very, very simple. All you need to do is substitute the value of m, which is -1.5, into the original function. Let's do that. F 5 times, minus 1.5 squared, that's minus 1.5 times minus 1.5, minus 2x, x is minus 1.5, minus 24, all right? So let's multiply it. 5 times 5 times 1.5, that's 11.25. There's no minus here because minus have cancelled minus. Plus 2 times 1.5 is going to be 3, minus 24. So let's calculate that. So it's going to give us Fm is equal to what? 11.25 plus 3 minus 24. That is going to give us minus 9.75. So straight away we can notice this and look at this very carefully. We can actually see that yes, you've gotten f of a, you've gotten f of b, you've gotten f of m. Now let's follow what I said. I said you should evaluate. That is step 3. Evaluate f of a times f of m. Whatever you get would give you an idea of where the root falls into. Like I said, in this question we'll look at 2 iterations. In the next question we'll look at 3 iterations. So f of a times f of m. Struggling to write this thing. Times f of m. That is going to be, what is f of a? F of a in the question is 27 times minus 9.75. Straight away we can see that the solution here is a negative number, but let's just write it. 7 times minus 9.75. That is minus 263.25. And this kind of question, like I told you, we are only concerned with the polarity, of the multiplication of these two, f of a times f of m, and f of m here was minus 9.75. F of a was 27. So it's going to give us a negative number. That means if you look at the number line, like the example I showed to you, you look at the number line and you have here a, you have here b, and here is m. If you look at this number line like this, that means since it's negative, that means of course there's a root between a and m. That means this is what you're going to be dealing with in the next iteration. You have no business with m and b because b is going to be wiped off. You don't need it anymore because you've already seen that the multiplication of the function of a and the function of m gives a negative number. That satisfies the condition for IVT, which says a function must change sign in a boundary. So it has changed sign here and we are good to go. So we're going to move to the next iteration. In the next iteration here, we're going to work in just a and m. So a is going to be the lower point and m is going to be the upper point. So let's get started. Let's get started quickly. Yeah. Oh, what have I done? I need to get this value. So let me just clean a part of this away. It's kind of slower because I'm working on my laptop. I'm not used to solving maths and working in my cursor. So yes, just bear with me. So the next thing we're going to do is the second iteration. All right. So yes, in this second iteration, I told you that our values are going to change. Our a is going to be the lower point, which was minus 3, right? A is equal to minus 3 here. And our b is going to equal to what? Minus, what was m? I think m was, let me find out again. M was minus 1.5, right? Yes. A is equal to minus 3 and M is equal to minus 1.5. So we're going to be working with this now very, 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 very quickly now. So yes, all we need to do is we have gotten f of A and f of M. We see that yes is less than 0. So there's no need to reaffirm or to reconfirm. So what we need to do is just to find this M for this second iteration, okay? So let's find the M for this iteration quickly now. There's no time. So M is going to be equal to A plus B a plus b all over 2, right? So m is, what is a? A here is minus 3 plus minus 1.5 over 2. So m is equal to minus 4.5 over 2. So m is equal to minus 2.25. So that means in this second iteration, your m now is minus 2.25. So you have nothing to worry about. The next thing you're going to do, right, is to find f of m for this second iteration. So we are in the second iteration of this problem, and let's get started. We have a, we have b, we have 2.25, right? So I think we are good to go. So let's get this done with quickly. So yes, next thing we have to do is to find f of m. All right. So let's calculate f of m now. I need notes. F of m is equal to, you have to substitute this value of m into this function, and our m here was was minus 2.25. So we're going to have 5 times minus 2.25 squared. Okay, squared. Right. I wish there's a way to make it better, but okay. Minus 2 times, this x here was minus 2.25 minus 24. So f of m is going to be minus 2.25 squared, 2.25 squared. That's 5 points. So let's multiply by 5 directly. That is going to be minus 25.3125, right? Plus, because this is 2 times 2.25. 2 times 2.25, 4.5 minus 24. So f of m would give, minus 25.3125 plus 4.5 minus 24. It's going to give minus 44.8125. All right. So this is minus 44 plus 8125. Now, if you want to move to the next iteration, we're going to look at f of a and f of m, and we're going to find out very quickly. We'll do f of a times f of m. I told you previously that is less than 0. That means good. You're going to make the boundary smaller. Your lower is going to be a. Your upper is going to be m. You're going to do it again. But if it's greater than 0, you're going to work with b and m. But because I told you that this example is stopping at the second iteration, this year we are putting a stop to this example. We're going to look at a new example right now, and it's really really fun because it's quite simple. Once you understand the concept that it has to do with it has to do with the fact that the interval is going to be divided at every iteration. This is the key to solving using bisection method. Let's try example 2 now, very quickly now. Example 2, the example given to us, let's look at it quickly. Let me divide it to 2 now, and let's look at this example. Say we have function of x is x squared plus 2x minus 5, and the interval given to us is 0 and 2. So let's work with this. Let's find the first iteration. Let's solve the first iteration, sorry. So we can follow the same process we did as the last example. The domain is 0 and 2. So let's move forward from here. Let's solve for the first iteration very quickly now. First iteration, let's look at this old function and use the bisection method just like we did for the previous example, sorry. So the first iteration would be solved thus. Our a, according to this, is 0 and our b is 2. We're going to find function of a, f of a, by substituting 0 to the function. That's 0 squared plus 2 times 0 minus 5, which is 0 plus 0 minus 5. So f of a is minus 5. So we'll solve for f of a. We're going to solve for f of b very quickly now. The same way, f of b is going to be, substitute 5 into the function given. Sorry, substitute 2 into the function given. 2 squared plus 2 times 2 minus 5. 4 plus 4 minus 5, which is 8 minus 5 and 3. So we found f of a and f of b, and let's find f of a times f of b to see if this satisfies the condition for the IVT. We notice that f of a times f of b is less than 0 because minus 5 times 3 is minus 15, which is a negative number, which is less than 0. That means very good. That means the question is correct, the interval is correct, and we are good to go. The next thing we are going to have to do is to calculate m, which is the midpoint, which will serve as the root in that particular iteration. So we're going to do that very quickly now. So let's see how we can calculate the midpoint. M is a plus b over 2. Our a is 0 and our b is 2. So 0 plus 2 over 2. So our m is 2 over 2. That is 1. That's the midpoint. So we're going to find f of m now before we go to step 3. This step 2, f of m is equal to 1 squared plus 2 times 1 minus 5, which is 1 plus 2 minus 5, which is 3 minus 5. That is basically minus 2, right? Yes. So like I said, we need to find f of a times f of m to see what we should do. That is, f of a is minus 5, f of m is minus 2. When we multiply the two of them, they give a positive result, which is plus 10. And I told us before that f of a times f of m must be negative for there to be a root between a and m. So as you can see that is greater than 0, that means the root does not stay between a and m. Let's look at the number line. A, b, midpoint is m. As long as f of a times f of m is greater than 0, according to statement number 3 I gave us before, that means we don't need that a side anymore. We're working with the second half of that interval. Okay? So that means in our next iteration, our a in the next iteration is going to be the m of this iteration. So we're going to look at that very quickly now. And we're going to solve the next iteration in a similar manner. So the last example, I like the fact that this one, the f of a times f of m is greater than 0. So now we're doing it in a quite different way because you see, look at the a here is going to be the previous m because we removed that former a side away because it was greater than 0. So our a here is going to be the previous m of the last iteration, which was 1, right? Then our b is going to still remain 2. What's the next thing that we should do? We found our f of m is just like the f of a here, so there's no need for repetition. So let's look at f of a, the same thing here, minus 2, and f of b is what we go for f of b in the previous question. What was that, Seth? F of b was what? 3. Okay, good, that's correct. So now let's find our m here. This f of a and f of b. If we multiply them beside is less than 0, that means it is good to go. That means the root is between this interval. So m is a plus b over 2, which is 1 plus 2 over 2, which is 3 over 2, which is 1.5. So that's good. Let's find our f of m for this second iteration. For this second example, we'll stop at iteration 2 now. I told you the result, if you were told to stop at a particular iteration, your root is going to be the value of m at that iteration. So f of m, substitute 1.5 into the equation, we have what? 2.225 plus 3 minus 5, which is 5.25 minus 5, which is 0.25. Let me show you very well so you can see it properly. F of b is 0.25. So multiply both of them, you have a negative number because minus times plus is minus. So the root here is going to be m because you're stopping at the second iteration. The root is going to be m here, the value of m, which was 1.5. As when you're going to the next iteration, you're going to look at the root at that particular iteration. Because we are stopping here, our root is going to be 1.5. So if they said your question should stop at second iteration, this is how to solve using the bisection method. As you can see, it's just based on the fact that the interval must be divided into 2. So it's quite simple. Once you have it in mind that bisection, okay, we're going to divide the interval into 2 at each iteration. It becomes very easy for you to solve this kind of numerical problems. So that's that about the bisection method. The next one we're going to look at is called the regular falsy method, and it's going to be uploaded soon. So make sure to like this video if this was really helpful. And if you have any questions or clarifications you want to make, kindly comment below. If I made a mistake or you want a better perspective, comment below and let me know your thoughts also. So thank you for your time. This is how to solve using the bisection method.